Okay, so I've decided to make a short video about the square root algorithm. These days with pocket calculators, it's very easy to get a square root, but it's an easy algorithm, an interesting algorithm that I never learned in school, and it's actually quite nice to do it. So I thought we'll start off just to have a quick look how it works. So if you've got a number 25 and you want to find the square root, the first thing you want to do is divide it in groups of 2, starting from the right hand side. Alright, then we start off with the 11, a square root that's less or equal than 11, and that is obviously 3. So 3 squared will be 9. If you subtract that, you will have 2. Then you bring down the next pair. Then you take the first, or the number on top, and you double it. So that will be 6 something. So what you want now is 6 something times that single digit that is less or equal than 290. So if you take, for instance, 64 times 4, that will equal 256. So it's less than that. 265 will be more than 290. So then the next digit will be a 4. And this will be a 4. And 4 times 64 is 256. And if you subtract that, you will have 34. Then you bring down the next pair of digits, 5. And like we did before, you take now the number on top and you double it. So that will be 68 and something, a single digit. So what we need now is a 6, 8 something times something that are less or equal than 3, 4, 2, 5. And if you take 5, 6, 8, 5 times 5, that will equal 3, 4, 2, 5 exactly. So this will be 5, and we've got a 5 on top. 3, 4, 2, 5. And then you're left with 0. So 345 squared is then equal to 119025. And that is the algorithm. So let's do another example. Say we've got the square root of 169, which we know is 13 squared. So again, we group it from the right in groups of 2. Alright, so we start off with the first group on the left, and something squared that are less or equal than the 1 will be 1, because 1 squared is 1. If you subtract that, you've got 0. Then you bring down the 6, 9. Then you take this and you double it. So you've got 2 something. Then you want 2 with a single digit times the same single digit that are equal to 69. And that just so happens to be 3. So the next digit will be 3 and 3. 3 times 23 will be 69, and you're left with nothing. So 13 squared is equal to 169. Okay, let's try another one. Let's try the square root of 10201. So again, we start from the right and we group them in pairs. And we start off with 1 squared is 1. If you subtract that, you've got 0. Then you bring down the next pair. Then you take this number and you double it. And then we want 2 something. So 2 something times that something equal or less than 0, 2. So obviously that will be 0. So if I write here 0 times 20 will be 0, and then you bring down, if you subtract that, you've got the 2, and then you bring down the next 2 digits, 01. And then you double this number on top. So you will double this, that will be 20 something. And again, you want 20 something times that same single digit that are less or equal than 201, and obviously it's going to be 201 times 1. 1 times 201 will be 201. If you subtract that, you're left with nothing. So 101 squared is equal to 10201. Let's try another example. Say the square root of 2. So what we're going to start off with is a square that's less or equal than 2, and that will obviously be 1, because 1 squared is 1, while 2 squared will be 4, so that's too much. If you subtract that, you will be left with 1. Then you bring down the next digits, 1 comma something. Okay, so the next digits will be 0, 0. Then you take the 1 and you double it, and you add a digit. Then we're looking for something, 2 something times something that are just less or equal than 100. And that will be 24 times 4 will be 96. So that's our next digit. 4 times 24 will be 96. If you subtract that, you're left with 4. Then you bring down the next 2 digits, which will be zeros in this case. Then the one on top, if you double that, you're going to get 2, 8, and a empty space. And again, we're looking for a 2, 8 single digit times that single digit that are less or equal than 400, as close as you can get. And if we take 1, it will be 281. Obviously 2 times whatever that will be more than 400. So that will be our next digit. 1 times 281 is 281. And if you subtract, you will get 119. Then you add or you bring down the next pair of zeros. Okay, so now we take the 1 for 1 and we double that, and that will be 282 and a add-on digit. So what we look for now is a 282 something times that single digit that are less or equal than 11900, and that just happens to be 4. Okay, so if we use 4, we will get to 11296. If you use 5, it will be more than this number. So the next digit will be a 4. 4 times 2824 will be 11296. And again, if you subtract that, we will be left with 604. And again, you can bring down the next digits. You take the 1414 and you double it, and you get a 2828 and add another digit. So then we've got 2828 something times that single digit that are less or equal than 60400. And in this case, it will be a 2, which you just check with simple multiplication. So 2 times that will be 56564, and if you subtract that, 3836, and you bring down the next digits. So that is fairly simple. Let's do a last one maybe. Let me see what enough. I'm sure I've got another example. Let's use 7,9. So the square root of 7,9. Let's add some zeros in pairs. So you pair them up from the right hand side. 2, 2, 2. So, okay, 7.9. Something times itself that are less or equal than 7, and that will be 2. 3 will be 9, so that's too much. 2 squared will be 4. If you subtract, you get a 3. Then you bring down the next digits. Then you double the one on top. That'll be a 4 with a something. We're looking for a 4 something times that same digit that are less or equal than 390. So if you have 46 times 6, that'll be 276. 47 times 7, 329. We're getting closer. 48 times 8 equals 384. And that will be our next digit. So 2,8 times that 48 will give 384. So if you subtract that, you are left with 6. Then you bring down the next digits. And again, then you double this one, that will be 56, and you add one digit. So you want 5, 6 something times that one digit less or equal than 600. And in this case, it's going to be a 1. Because if it's a 2, it will be more than 600. So you add that 1 times that will be 561. You subtract, and you're left with 39, and you bring down the next digits. Now you double the 281, which will be 562, and you add on that one digit. And so you want 562 something times itself less or equal than 390. 0. And obviously if you add a 1, it will already be too large. So this is going to be a 0 again. So we're going to add a 0 times that will be zeros. When you subtract, you're left with 3900, and you bring down the next zeros. Again, we double the one on top. That will give you 5620 and something. So you've got 5620 something times that digit less or equal than 390000. And just to make this short, we will be using a 6 because that equals 337236. So if we place a 6 times that, you've got the 337236. And if you subtract 3449, and you can bring down the next digits, and so on and so on. So it's a very nice algorithm, very nice to use. It's not quite as straightforward because you still have to work out a few of the answers to find the right solution. But it's a nice algorithm which works out the problems very nicely.